All right, ladies and gentlemen, we are on the final video for preparing for Precalculus. And in this video, what I want to do is go over some problems in trigonometry that will help you prepare you for the trigonometry that we're going to be doing in Precalculus. So a lot of these you've probably come across either before geometry class or even in geometry class. And you'll see what we'll have is we'll start with just the Pythagorean theorem, kind of reviewing the Pythagorean theorem. Then we'll talk about evaluating trig expressions or using trig expressions to evaluate different parts of the triangle. And then last but not least, we'll deal with special right triangles, which would be very helpful for us as far as understanding some of the relationships in trigonometry. So let's go ahead and get started here with our trig. And if you can remember when we're doing the Pythagorean theorem, there's kind of special relationship that we're going to want to deal with that. Let's do 300% here, is remember that Pythagorean theorem relationship. And that means as long as we have a right triangle, it's really hard to draw a right triangle. I guess I'll try to do my best here. That's a horrible right triangle, but that's going to be okay. If we have a right triangle, we have that little squares representing 90 degrees as a right triangle. And that's everything that we're going to be based on today is all my triangles are going to be 90 degrees. You can see I kind of provided the box there for you. And there's three parts, or there's two sides, what we call, of our triangle. We have the two legs, which we label as A and B, and you can label them really as any letter you want to. And then you have your hypotenuse, which is always directly across from your 90 degrees, as we'll label that as C. And the hypotenuse, remember, for a right triangle is always the largest side. And good old Pythagorean theorem basically states if you take the leg squared and add it to the other leg squared, that's going to equal the hypotenuse squared. So that's basically what we're going to do here to solve these is we're just going to find the missing side by applying this relationship. Now, I don't really care if I'm going to call these A and B, and that's why I kind of move the triangles around, because it doesn't really matter which one you call A or which one you call B. We're just kind of more interested as far as determining leg squared plus leg squared equals hypotenuse squared. So let's go and look at this. You can see here that my hypotenuse is what I'm basically the missing side that I'm solving for. And I have my two legs. So therefore I can write a relationship. 3 squared plus 2 squared is going to equal, now this is a missing side, so maybe we'll just call this x, equals x squared. All right, 3 squared is going to equal 9 plus 2 squared is 4. Equals x squared. You know what? I am going to zoom actually in for this and maybe even try to do a little smaller. Now 9 plus 3 is going to be 13 equals x squared. Okay, now again we need to solve for x, so to undo squaring we're going to want to introduce the square root. Now introducing the square root, we usually always take the positive and negative, but it doesn't make sense in the context of these problems to have a negative side length, so therefore we're only going to use the positive value, so therefore x is going to equal the square root of 13. So the missing side length of this triangle here is going to be the square root of 13. So I can just say that's equal to the square root of 13. Okay, so now in this case you can see that my hypotenuse here is going to be 7. Right? And then we have a missing leg here, which is going to be 5. Now, again, we can call this x. Sometimes we'll call this A, B, R, H, whatever you want to call it. Or L, that's for like a leg. But let's just keep it with x. Now, we notice, again, the Pythagorean theorem is x squared plus x, or leg squared plus leg squared equals hypotenuse squared. So, therefore, my relationship on this one is going to be, x squared plus 5 squared equals 7 squared. And a lot of times it's helpful to put those in parentheses just to kind of remember that we're plugging them into the formula. So here in this case we have x squared. 5 squared is going to be 25. And 7 squared, is 49. Now to solve for x squared, I'm going to subtract the 25 on both sides. And therefore I get x squared is equal to 24. Now we got to go back and remember that simplifying radicals, because I can't take the square root of 24. Here I couldn't take the square root of 13, but I couldn't simplify it either. Well, here when I introduce the square root here, I have x equals the square root of 24, and that can be simplified because I could rewrite that as the product of 4 times 6. And I can take the square root of 4, but I can't take the square root of 6, so I could also rewrite this answer as 2 radical 6. Okay, so just make sure you're aware of all of those different, kind of notations for that. All right, last but not least here is, again, you can see that we are given the hypotenuse, which is 5. So we're given this other missing side, which we'll call x again in this case. And again, you can, really use it however you want to for that. So now in this one, I'll have 4 squared plus x squared equals 5 squared. And when I take the square root, square it, I get 16 squared plus x squared equals 25 squared. Now when I subtract 16, I get x squared is equal to 9. And therefore, I'm kind of running out of space here, but I can take the square root of 9, that's going to equal 3. And let me go and put this answer here. This one is 2 radical 6. Okay, very good. So there you go, ladies and gentlemen. That's one where you're going to have an integer side, which is great. Not always is that going to happen. Sometimes, a lot of times, we're going to deal with just radicals, or then also radicals that can be simplified. So we just want to make sure we understand at least the relationship, which is leg squared plus leg squared equals hypotenuse. So make sure that you always identify the hypotenuse first and just plug them in. And again, you can use the same variables A, B, and C, or you can use X or any other really letters that you choose. All right, our trigonometric relationships. So to determine the missing side of the triangle using our trigonometric functions, the angles are in degrees. So I had a little issue when I was entering these on there. I wasn't able to put little degree symbols, so I will take the time now to go ahead and do that. The couple important things that we need to remember is our trigonometric ratios, and I'm not going to get too detailed because I go over this completely again in our lesson. But the important things to remember is when we're dealing with a triangle, and let me see if I have, well, I'll just do space here. When we're dealing with a special triangle, okay, again, it's a right triangle. And, we're dealing with an angle. Okay, we always called this the hypotenuse. Right? That side is the hypotenuse, which we discovered from that's the hypotenuse from the Pythagorean theorem. Well, the side, and that's because that's directly across from the 9 degrees. Well, the side that is directly across from the angle that we're talking about in reference here, in this case, we'll use theta, which represents the angle. That is what we call the opposite side. And the side that's between the angle and 90 degrees is what we call the adjacent side. And this is important because this brings up our 3 trigonometric ratios, which probably most of you just have memorized as like SOHCAHTOA. And, I'll go back and like relay them again, what they represent. And, even if you're like, I know what to do or I remember doing it, but I don't understand it, that's fine. That's what we're going to get in more detail in the class. But the main important thing is understanding that the sine of the angle is equal to the relationship of the opposite side over the hypotenuse. And the cosine of the angle provided is equal to the relationship of the adjacent side over the hypotenuse. And the tangent of an angle is equal to the relationship of the opposite side over the adjacent. So that is something that we discussed in geometry class, and we'll get in more depth here. But the main important thing is when we're looking for trig, we're trying to find this missing side, right? And so here you can see we have x labeled. So that's what we're trying to find x. Now, we're not given the hypotenuse. Otherwise, we could use the Pythagorean theorem. But we are given our angle of 43 degrees. And actually, I should probably put an arc there. So that is our angle in question. And in this case, that is our theta per our definitions. So how do we figure out this? Well, what we need to do is determine what are we given. So if you see here's your 45 degrees, this is my hypotenuse, and this is going to be the same for almost all these problems because you can see I have all the same triangles, right? So the angle and the 90 degrees are in the same spot. So our hypotenuse, opposite, and adjacent are in the same side. So this will be my opposite side, and this will be in my adjacent. And just a little forewarning, again, remember that this all changes based on where my angle is. So for instance, if I use alpha, just again a quick thing, if I put my angle up here, well then this is no longer the opposite side, that's now the adjacent side, and this is the opposite side. the hypotenuse never changes, okay? So just a quick little disclaimer just to make sure we're all on the same page. All right, so now what I need to do is I need to understand which trigonometric then relationship is going to work with this. So if I'm dealing with the opposite side and the adjacent side, you see that the only trigonometric function that deals with opposite and adjacent is my trig, or is my tangent function. So I'm going to write this relationship as the tangent of my angle. In the formula is theta, but you can see here we're provided 43 degrees is equal to the opposite side over the adjacent side. So opposite over adjacent. So that's going to be x over 6. Now, our idea here is to solve for x, right? So right now my x is being divided by 6, so therefore I need to multiply by 6. So what I'm going to do is I'm just going to multiply by 6 on both sides. And I can see x is equal to 6 times the tangent of 43 degrees. I hate how that does that. Okay, and now all it does is comes into plugging this information into your calculator, which I don't know where my calculator is. There's my calculator. Now, I'm using a TI calculator, and I do have the software that, I'll possibly go over into some different lessons in today, but it doesn't really matter. All you need to do is have a scientific calculator. The main thing when dealing with trig is to make sure that your mode is in degree mode, and then all we're simply going to type in is exactly how I have it written there, tangent, or 6 times the tangent of 43. And I said to round to 3 decimal places, so the answer that I obtain on my calculator is 5.595. Okay, and that can just be written as units because we're not talking about any other units that we're dealing with. Okay, and the next one, again, you can see that, all right, well, here's my angle in question. So again, this is my opposite side. That means this is my adjacent, and then this is my hypotenuse. So which trigonometric function deals with adjacent and hypotenuse? Well, you can see that's the cosine function. So let's go and write out the next one. I'm going to have cosine then of 43 degrees is equal to my adjacent side over my hypotenuse, which is x. Now this one isn't as nice because here all I had to do was multiply by 6, and then I had my x, once I divided by 6, those divided out, right? And I was just left with x, and I just flipped the equations around so my x was on the left-hand side. But here, if I multiply by an x on both sides, I don't isolate the x, right? Now I have x cosine of 43 degrees equals 4. So to get rid of the x, I got to divide by cosine of 43 degrees on both sides. And this one gets a little tricky because it's, a little extra work with students, and so sometimes they get a little confused. So therefore I have x equals 4 over the cosine of 43 degrees. Now I can go ahead and plug that into my calculator, and exactly how it is, just do 4 divided by the cosine of 43. And I get 5.469 is being round. So x is equal to 5.469. Okay. All right, let's move on to the last one here. You can see this one where here's the angle. So we're dealing with the opposite side and the hypotenuse. Why does that to me? So the hypotenuse here is going to be your sine. So I'll just write this out relationship. Let's use again green. So we have sine of 43 degrees is equal to opposite over hypotenuse. Now in this case, you can see I'm just going to multiply by 5 on both sides. So to kind of save some work here, I'll just write 5 times the sine of 43 degrees. Just multiplying by 5 on both sides, obtain that. So I'll just type in 5 times the sine of 43 degrees. And I get 3.4099918. So therefore I round that up. That will be 3.41. So x equals 3.410. And you could leave the 0 off, or you could add it in there as well. All right. So that goes into our trigonometric relationships. Wrong way. Now let's go and get into our special right triangles. Now, when dealing with the special right triangles, you probably have forgotten, because every year that I teach this, most students do not remember special right triangles relationship. So it's a very, very good lesson that I like to go over in geometry to explain and just show you these relationships. It's not really necessary to know because, obviously we could either use the Pythagorean theorem or we could use trigonometric functions, right? But I think when understanding the trig that we do in precalculus, understanding the relationships of special right triangles makes everything connect, as well as obviously knowing special right triangles is kind of like a little bit of a trick. I mean, it's like difference of two squares and, perfect square trinomials. It's the same thing, but it just makes things go a little bit faster, as long as you understand the relationships. So basically the relationship here is you can see these first two triangles. I have triangles that are 90 degrees, right? And they are right triangles. So I'm just going to add a little other thing in there. Sorry, still at school, so they make online announcements. All right, so the main important thing we need to understand is the special right triangle relationship for 45 degree triangles. So I'll draw another 45 degree triangle here. A little bit better, not too bad. All right, so as long as we have a 90 degree, as long as we have a 45 degree triangle, 45, 90 triangle, let's just say we have one of our legs is x. Who knows what x is? If it's a 45 degree triangle, 90 degree triangle, it's what we call an isosceles triangle. The two legs are actually going to be the exact same length. Now, you can test this on your own. If you apply the Pythagorean theorem to find the length of the hypotenuse, go ahead and apply the Pythagorean theorem. For save time, I'm not going to do it. You would get x times the square root of 2. So what's important here is if you look at this triangle, I have 2, 2. I need to figure out what the hypotenuse is. Well, notice, to go from the leg to the hypotenuse, all I need to do is multiply by the square root of 2. So I'm just going to take the leg and multiply it by the square root of 2. And that's it. That's how quick it was. You could have done Pythagorean theorem if you wanted to. 2 squared plus 2 squared equals 4. Or 4 plus 4 is 8. Square root of 8 is 2 squared of 2. All right. Now, here's where it gets a little tricky. You can see the hypotenuse is 1. So, again, it goes into that relationship. To go from the leg to the hypotenuse, we multiplied by the square root of 2. So, to go from the hypotenuse to the leg, we're going to want to divide by the square root of 2. So, I take 1 and divide it by the square root of 2. Now, that's perfectly fine the way that it's written. However, preferably you're going to see where you're going to simplify this by rationalizing the denominator, and that's going to be the form that you're most often going to see this. So it'd be square root of 2 over 2. And since the two legs are exactly the same, I'm going to have square root of 2 over 2. Okay? Now let's get on to the 30, 60, 90 triangle. Now the 30, 60, 90 triangle, let's kind of redraw one over here as best I can. So that just looks so bad. Okay, let's try that again. You got to have your long leg and your short leg. Okay, and so therefore that's 60 degrees, and that is your 30 degrees. Okay, so the way that the relationship of 30, 60, 90 works is actually half of an equilateral triangle, and that's how you can use the relationships to find everything we need. But anyways, if the relationship basically goes, and this is what you just need to I just want to expose you. I'm not really too concerned really how well you remember your special right triangles. But the short leg, if we're going to call the short leg x, then the hypotenuse is going to be 2x, and the long leg is going to be x times the square root of 3. Okay, so just understanding that relationship, and again, I have, you can use Pythagorean theorem to verify this, and that is the relationship for all 30, 60, 90 triangles. It doesn't matter what the side lengths are. So in this case, you can see, for the first example, you can see here we have 3. Well, if I know that the short leg of a 30, 60, 90 is 3, then I know that my hypotenuse is just going to be 2 times 3, which is equal to 6. And then to find the long leg, I'm just going to take my short leg and multiply it by the square root of 3. So that becomes 3 square root of 3. In this next one, again, you can see that now I'm given the long leg. And again, going back to that relationship idea, if you're given the short leg, to go to the long leg, you multiply by the square root of 3. So to go from the long leg to the short leg, you're going to have to divide by the square root of 3. So in this case, I'll have 6 divided by the square root of 3. Now again, we're going to want to simplify this. So if I multiply by the square root of 3 over the square root of 3, I'm going to get 6 square root of 3 over 2, which can be simplified to 3 square root of 3. Okay? Then, to go from the short leg to the long leg, all I need to do is multiply by 2. What the heck happened there? What the heck happened there? So therefore, I'll have 2 times 3 square root of 3, which is just equal to 6 square root of 3. And that's your hypotenuse. All right, last but not least, here is going to be here the hypotenuse is 1. So again, let's go back to the relationships here. If the short leg is x, then the hypotenuse is 2x. So to go from short leg to hypotenuse, you multiply by 2. So to go from the hypotenuse to the short leg, you're going to divide by 2. And then to go from the short leg to the long leg, all you're going to do is multiply by the square root of 3. So I'd have the square root of 3 times 1/2, which is just equal to the square root of 3 over 2. So there you go, ladies and gentlemen. That is your roundup for trigonometry. If you have completed all of my parts 1 through 6, I feel very comfortable that you will be prepared and have the necessary ingredients to be successful in precalculus. Enjoy, and I look forward to helping you further. Take care.